In this problem, we want to integrate a function that is defined on a square, but just over part of that square that satisfies x times y is less than or equal to 1. So as we have been doing, let's sketch this region. So the easy part is to sketch just the region 0, 2 crossed with 0, 2. It's just this square. And the slightly more difficult part is to sketch the inequality xy is less than or equal to 1. So remember, the thing that we want to do is rewrite this as y is less than or equal to 1 over x. So we know the general shape of this curve. It looks something like this. Now we just need to figure out where it crosses the two orange lines. So where does it cross this line? Well, when it crosses this line, y is equal to 2 at that line. So 2 is going to be equal to 1 over x. So this means x is equal to 1/2. So that's 2, that's 2. This is roughly 1/2. And similarly, when it crosses the vertical orange line, y is going to be equal to 1/2. So it looks something roughly like this. And we want the part that is less than or equal to this line. So in other words, we want this region here. Okay, now you can integrate this either having the x integral on the inside or the y integral on the inside, but there is an annoying thing that we have to deal with. I'm going to do this with the x integral on the inside. So what this means you can do this integral with either the x integral on the inside or the y integral on the inside. But whichever one you do, there's an annoying problem that you have to deal with. I'm going to do this with the x integral on the inside. So notice that for y values going from 0 to 1/2, x is going to go from 0 to 2. But then for y values from 1/2 to 2, x is going to go from 0 to this blue curve right here. That is, x is equal to 1 over y. So we have to split this integral into two integrals. The first integral, the outer integral, is y. It goes from 0 to 1/2. The inner integral is x, and it goes from 0 to 2, and we're integrating the function x plus y, and then dx dy. The second integral, the outer integral, goes from y equals 1/2 to y is equal to 2. And now the inner integral goes x equals 0 to 1 over y, x plus y, dx dy. Now for this first double integral, the inner integral is x plus y, and we're integrating that with respect to x. The antiderivative of x is x squared over 2, and we're going from 0 to 2. So that's 4 over 2, which is just 2, plus y. The antiderivative of y with respect to x is just x times y. So this is 2y dy, plus the integral y equals 1/2 to 2. The antiderivative, again, of x is x squared over 2. So this part is 1 over 2y squared. And now we're integrating the function, the constant function y, from x is equal to 0 to x is equal to 1 over y. So that's 1. This, as you can verify on your own, is equal to 3.5.